Hello everyone, Jimmy here, and welcome back to episode 15 of Omnifactory. Our base is starting to get pretty expansive, although it's still all flat and very simple. Well, never said building was my strong suit. But I did learn something pretty cool today. So in the networking tool, right, which is Applied Energistics debugging tool, we know that if you right-click a network component with it, you get this screen, which has a bunch of information about what's on the network, how much energy it's using, etc. But I just learned that if you shift right-click it, you get this inventory where you can store these, like all your cards. And if you open any inventory or any like Applied Energistics component that has room for these cards, you can just you can like put these cards in here, and basically it's 9 more inventory slots only for these cards if you have one in your inventory. Previously, I thought that if you don't have these in here and you open one of these, I thought this was like part of the device, not part of your inventory. So today I learned, and maybe today you learned. So moving on, between episodes, I went ahead and added a couple more metals to our blast furnace production. It's very much similar to what we had before. These are just crafting components we'll use very shortly. So stuff like vanadium. This one over here I think is for high strength steel type G, or high speed steel type G. Vanadium gallium. A couple others, nothing too exciting. Niobium. And niobium titanium. These are exotic-ish alloys. We'll only use in rather small quantities, but we will need them. And the reason we'll need them is that I want to get to tier 5 microminers today. So, if we look at tier 5 microminers, let's look at its uses first. There's 2. First, we can use it to get a plethora of different ores. There's a couple in here that are pretty rare, but like monazite, sphelerite, and bastnasite, pretty valuable. I don't think we'll launch this mission very often. But more excitingly, we can use it, and this is tier 5 microminers represent the only way to get Naquadah Dust. Naquadah is a pretty exotic and interesting material for you Stargate fans out there. I'm sure you already know, but it is, supposedly some like ultra rare energy dense stuff that has very cool uses. The coolest use for us, at least immediately, is to make, if I can spell it right, somewhere in here, there are Naquadah coils. Here we go, Naquadah Oil Blasts. And if you look at their temperature, they are the second or third highest or fourth highest temperature coil block. They have a 16x multiplier in the multi-smelter. That's pretty cool. We can do 4 stacks at a time with them. But they can also be used to make Enderium. So Enderium has to be made in a blast furnace at 6400, and Naquadah is the first material that is hot enough to do it. So let's look at what it will take to make that tier 5 microminer. Most of these components aren't bad. We either already make them, or it's, tier 4 circuits, EV tier stuff, whatever. Scandium plate we already make. This just takes an extra chemical reactor. There are 2 parts, though, that are new. So in the vibrant thruster, there is a prescient crystal, which has to be made in a soul binder. The only thing that's kind of challenging is the soul binder, but even that's not bad, right? It's only 4 pieces of tungsten steel and a bunch of basic components. We just have to set that up. But what is a little challenging is that this iridium heavy plating is made by Iridium, which we have tons of if we take a look. Yeah, we have 3,000 iridium with another 1,400 iridium dust, so that's not a problem. But, whoops, there's a spoiler. Iridium heavy plating has to be made, if you look at the energy usage, it has to be made in a Ludicrous voltage tier compressor. The Ludicrous voltage tier compressor uses tier 6 circuits. That's easy. This is why we had to make niobium titanium. The machine casing is just lumium and vanadium gallium. That's fine. But the electric piston has to be made in an assembly line. And likewise, the motor in it has to be made in an assembly line. So it's high time we built an assembly line. Now, if we look at the quest for an assembly line, for some reason my quest text is spilling over, but it takes a whole lot of blocks. And if we look at the way it looks, it is a large multi-block, and we'll need a long assembly line. Maybe, let's just go straight for the max length one, and we'll need 2 of these eventually. So if we're going to build one, may as well build 2, right? So yeah, it's a lot of components, but I think we have all the materials we need to craft it. It's just a matter of letting auto crafting do its job. So I'll be back when we have everything gathered up. One inventory full of components later, and I think we're ready to put together our assembly line. Let's have at it. Hey, it formed in our first try. That's impressive. So I choose to build it awkwardly floating off the ground because all the inputs are on the bottom middle. And if you build it on the ground, you can't access any of them without digging under it. I guess I can build some supports for it after. But let me build the other one off camera, and I'll be right back. 2 assembly lines held up by OSHA-approved frames. Trust me, the inspector said so. It'll be fine. So next we have to do is hook up the item inputs to these. Now the way item inputs work is that each assembly line has, I believe, 15 of these single slot input buses, and you just have to make sure that they don't, when you put the items in, that they get distributed between these input buses such that it forms a valid recipe. Another thing is that there are 2 different types of the program circuits in these. So there's ID 1 and 2 for conveyors and pistons respectively. That's why you need 2 of these. You can actually put both program circuits in one, but then you have to deal with recipe conflicts, and there is just not enough room to do every single recipe in a single assembly line. But that's fine, doing 2 isn't a big deal. So let me hook up the item inputs and I'll show you how it works. And it's really a lot simpler than you might think it would be. And here they are, all wired up. So first of all, they need fluids. That's pretty easy. For now, they only need soldering iron and lubricant, and those are supplied by fluid export buses. Now for the item side, the interface that we want to use for it has to be on blocking mode, and we have to use a buffer chest. So from there, we want to extract out of the buffer chest without round robin mode. It's important. Do not use round robin mode. And because the recipes often involve a lot of items, it's pretty good to just stack up your extract speed upgrades to the max. Then on each of your input buses, just have them all set to input all the way through to the very end. And on your last one, because that's the output bus where the final product goes, you just set it to extract, and then we can dump the items back in the interface when they're done. So with this, our assembly line should be set up, and we can start auto crafting the high tier motors and pistons. Now for conveyors, there's another step we have to do, if I can spell conveyor. All the high tier conveyors from Ludicrous Voltage and on take this styrene butadiene rubber. For some reason, I thought the rubber we made earlier was this, if you remember, the rubber we made when we were doing hydrochloric acid. this rubber. Well, the top side of our base has gotten really laggy. But this silicone rubber, I thought that was the same stuff. It turns out it's not, so we have to do something about that. I guess the silicone rubber is just going to be basically useless. But when we want to start making rubber, or start making conveyors, we have to start making some of that styrene butadiene rubber. But that's okay, we don't need that yet. So with this setup, though, we can now make our compressor. Right, we should now be able to make the Ludicrous voltage compressor, because that only uses pistons and motors. So let me start the process of crafting these, and we can go back to our original goal of making tier 5 microminers. And now I think we will hopefully be able to order 8 of our Ludicrous voltage compressors. That looks good. This process will take quite a while. It takes a lot of circuits, and these the high-speed steel rounds take a long time to make. So let's start it up. In the meantime, though, let's start working towards the other component we needed, which was a soul binder. And a soul binder has to be made in the 5x5 crafting table. And besides that, though, it's all basic components. The heads we can get off of Deep Mob Learning if we need it, so I'll make one of these really quick. Here's a couple soul binders. We'll need a lot of soul binder recipes for later, so having 2 of them just lets us split up the recipes. They're a key part in some very important alloys later on. The soul binder needs some liquid EXP to work, so I just have a fluid extractor turning some of our, 500k extraterrestrial matter into EXP. And then we can just pipe it into the soul binders with an export bus. And just in time, the last of our compressors are finishing up, so let's head back upstairs and begin the process of upgrading. So, much like before, all we have to do is rip out, let's take these capacitors out, rip out the CEF, all the machines. One of the few times when vein mining your machines is the right thing to do. And the wires. Place them with the new CEF. And the new wires. And lastly, we put the machines back. I suppose we need to get the new machines. And easy as that, we've upgraded. Now, these take a lot of power each, right? Over 100k RF each, or over 100k RF a tick each. I'm not actually sure we can power all 8 at once. We might actually have to turn some of them off for now. But, actually, yeah, we definitely can't power all 8 at once now that I think about it. Let's only use 4 then. How can I do that? So I guess we only had to make 4, but oh well, we made all 8. Alright, anyways, let's go back to making our microminer. So here we have gathered all the components for the tier 5 microminer. But if you look at it, there are 10 components here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the pattern terminal can only put 9 items, 9 different items into a single pattern. So we run into a bit of a problem. Good news is there's a tool to help solve this, and that's called PackagedAuto. Yeah. Here we are. So PackagedAuto adds this block called a packager, which uses, it's not that bad, right? Tier 4, bunch of titanium, that's fine. So what the packager can do, though, is it can take up to 9 items and turn it into a single item package, which you can transport around. And then when you get to you can send that item package to an unpackager, which will then turn that item package back into the up to 9 items that went into it. That way, we can encode patterns with more than 9 items in it, effectively speaking, by using packages. So let me build these components and show you how it works instead of just telling you. So I set myself up a little working space here in the basement where I get a little bit more FPS. But anyways, for now, I set up 4 packagers with 4 package recipe encoders. And if we go into these, each package can hold, 19 recipes. But each packager can only process 1 at a time. So I don't like to overload these. I generally only put 4 or 5 recipes into each. So the way you encode a recipe then is, let's just do the one we're doing now for the Tier 5 microminer. First of all, every single recipe is encoded as processing type, not extreme crafting type, because our extreme crafting isn't with Avaricia, it's with the other mod, extended crafting. So, Tier 5 microminer, we can still shift click it in. It looks all messed up here, that's fine. It has the right number of components. So all we have to do is, once we put the recipe in, we hit the save button, and that encodes it into the recipe package holder. We take the recipe package holder and put it into our packager. And I like to keep 2 copies of each of these. Think of it kind of like development versus production environments. The one that's in your recipe encoder is the development environment, and the one that's in the packager is a production one. So that way, if you mess up your development environment, that's fine. You can make a copy from production and reset to there. Anyways, packagers are the next step. They require a little bit of power, and they must be connected to your ME system. So you see here, this packager has both power and ME connections. And then when we put the recipe encoder there, and go into our ME system, we can search for the microminer. And because we encoded that recipe, we now see that there are 2 packages here, one of index 0 and one of index 1. So let's take all of our components for the microminer and put it back in our ME system and request one of each of these. And that's very easy because we already have all the components. So now that we have both of these, we can add a new recipe that says one of index 0 and one of index 1 will make, let's start here. To craft a tier 5 microminer, we need an index 0 and an index 1. And to craft these, right, we need those 10 different items. So that's how you get around the 9 item limit in pattern terminals. So now that we have this recipe, we need an unpackager, as well as all of our extreme crafting automation. So this is in the tier 3 7x7. So we need a tier 3 crafting table, the automation interface, as well as the unpackager when it's done. We'll grab that in a second. We come back over here where we have the rest of our automation for these things, and setting up the crafting table is the exact same. So it's a crafting table, automation interface. Now, where we normally have the ME interface, this time we want to have the unpackager and then the ME interface. And I have to go rename this interface, so I'll be right back. And we're back. So I renamed our microminer. I put the Z in front of it, or our interface. I put the Z in front of it because I want it to be at the very bottom of our interface terminal, because we probably don't actually have to interact with it much through there. So we hook up the interface to the ME system. We hook up the power to everything else. And then we can, let me see how these are configured. So these we had auto pushing the final result up. This time we don't want that because the block above the automation interface is the unpackager, not the ME interface. So we want the other settings to be the same, but now we have to manually extract the finished product. Nothing a few item conduits can't do. All right, we put our pattern into the terminal, or into the interface here. And remember, the pattern now sends the 2 recipe packages into the unpackager. There is a recipe holder slot in the unpackager. Leave it empty. And does blocking mode matter? No, it doesn't. So now let's go request a tier 5 microminer. Now the first one we request, since we already have these packages, it'll just grab them and send them. But they'll just sit in here for a second because we haven't set the recipe in the table yet. So let me grab all the materials manually. We'll put them into the crafting table. Remember, don't take the product out, go into the automation interface and click Save Recipe. That'll save the item here, and then it'll get pulled out. And the first one is done, but that one was manual. Let's request, can we do 7? We can. So let's request 7 and see how long that'll take. I think the bottleneck in this process is these engine cores, which take a good 20 seconds each. But let's give it a minute and just see how it progresses. This shouldn't take too long overall, because I think our crafting process is pretty optimized at getting rid of all the bottlenecks. Except the one. The engine cores. Whoops. But anyways, this is one of the uses of the packaged auto system. So doing it this way, we can send more than 9 items at a time to our crafting requests without using wonky workarounds or hacks. There's ways you can do it in vanilla applied energistics, but it's a lot more difficult than just using packaged auto. The other thing we can do with it, though, is let me just start encoding another recipe. So, you know what? Let's say we want to be able to process these microminer engine cores faster. We can actually just encode this as a recipe. Click Save. Grab this package holder. Put it in here. And come back to here and back it up. So now if we look at engine core, we now have another package that says you can craft 1 Signalum microminer engine core out of these items. The final product doesn't matter. It's just when I request this recipe package, it will take the 4 blocks of redstone and the engine frame and put it into a single item. So that will take it a couple seconds to process. But what I can then do is grab another unpackager, which let's just craft 10 of these. We'll need a lot of these. And if I make a small array of alloy smelters, the normal problem, right, is if you try to automate alloy smelters by having a bunch of them run in parallel like this, is that if you just have a chest here and then you round robin extract, well, you might end up with, the empty frame in this alloy smelter, if it was an alloy smelter, and then the redstone in this one, and it'll get jammed. But the way packaged auto gets around it is that the items, the redstone and the empty frame, stay together as a recipe package until it reaches a unpackager. And when that happens, the unpackager splits the items up in one unit and transfers them into the same, ensures that it goes into the same alloy smelter. So it looks like these are in the process of crafting now. Let's watch this process finish, and then I'll show you exactly what I mean with that alloy smelter distribution system. Oh, looks like it finished that one up. Let's see when the next one's coming. So as soon as that finishes, I expect that we will be seeing one craft. And we were late again. It's done. Well, whatever. We can see that the process of crafting these is now fully automated. So let me set up that alloy smelter parallelization system, and I'll come back and demonstrate it to you again. So here is our distributed alloy smelter setup. There are 8 total IV alloy smelters. Each one has an unpackager feeding it, and the items are fed into the unpackager by the ME system. So here are the patterns. If you see, the magic here is that we can now say that one item makes one item, and that way a single item is atomic, right? You can't split it up into smaller packages. That way you guarantee that all the components. That doesn't work. Right, that wouldn't work. Whatever. So you can guarantee that all the components reach the same alloy smelter. Oh, that does work. Right, so let me show you what these recipes actually look like. So it says that one of this recipe package makes one of this item, right? So the microminer engine core is made of 2 blocks of redstone and a microminer engine frame, and that's what makes this recipe package. Likewise for this one, it's 4 blocks of redstone and 1 Sydneyland microminer engine frame makes the engine core, which is a recipe. So if we take these recipes, put them into the ME interface, and I took our existing ones out already, and let's request the engine cores now. Remember, before this was pretty slow to craft, right? Because it took it a fair amount of time to actually do the alloy smelting step. So let's ask for 40 of them. And if we see, it still has to make, all the rods and the plates. But as it starts, or as it produces those, the recipes are able to be distributed between multiple alloy smelters, and the result is that we can process them in parallel. So right now there are, 3 or 5 alloy smelters running, processing that one recipe. And that this way, we've eliminated the bottleneck to our on-demand crafting. Isn't that cool? We can use this similar setup like this to make parallel running blast furnaces as well. So when we do stuff like tungsten steel, right, which has 2 inputs, the tungsten and the steel, we can guarantee that they end up in the same blast furnace. And in fact, this type of parallelization trick we'll use everywhere now. It'll really be a key part of our base design that allows us to do fast on-demand processing. So now that I've had a chance to demonstrate this, let's go back to our original project, which once again was microminers. It looks like our first 8 microminers are complete, and let's see what it'll take to launch them. So the quantum flux we already know how to make, but we need stabilized plutonium, which is made from solidifying the molten plutonium. So let me set up a system that'll melt and then solidify plutonium for us, and then we can send these microminers on their way. And for stabilized plutonium making, and for the other stabilized isotopes, we have another case of distributed parallel processing. So let's take a look and request some stabilized plutonium, maybe 500 of it. Can we do that? Looks like we can. So what it'll do is it'll put the plutonium into here that's to be melted. That gets distributed amongst the fluid extractors. And then each fluid extractor feeds into a fluid solidifier of its own, which is able to turn it into this stabilized plutonium. So with this, we can rather quickly, once again, make all the stabilized radioisotopes. And for now, we're using this stuff as launch fuel for our microminers. Although going forward, it is also a key component in Omnium. And once again, every episode we get slightly closer. And in fact, I think probably within a couple more episodes, we'll be able to make our first few pieces of Omnium. And that unlocks a whole world of opportunity. So let's see how much launch fuel we need for this. 32 each, so we need 4 stacks of stabilized plutonium. Looks like we have that. And the other fuel we need is quantum flux, 2 stacks of it. So let's just request a couple hundred of that. 1 stack. Two stacks. All right, let's go launch it. So over to our medium microverse projector, put everything into the input hatch, and off it goes. I'll be back when it's done. Some of our microminers have completed their missions and brought us back some precious Naquadah Dust. So as I mentioned, the first thing I want to do with this is to make coils with it so that we can power our Enderium making blast furnace. With the blast furnace now set up to make Enderium from Enderium blend and a little bit of primal mana, I think it's time we set our sights even higher. The next valuable thing, or the next, tier of thing we'll be making will be Draconium. And that's right, folks. We are almost at the stage we can get into Draconic Evolution. Now, Draconium's a little bit more difficult to make in this pack than normal. You know, it has to be made in a blast furnace, and it has to be frozen afterwards. Good news is, Draconium Dust actually has a pretty easy chemical reactor recipe. Dragon's Breath is just cetane boosted diesel, which we have boatloads of, and blazing pyrotheum, which we can easily make boatloads of. And Manulin is just a mixture of Ardite and Cobalt. And Ardite's not all that bad. We're already making it for Signalum, I think? Something or another. Anyways, so to cook hot Draconium ingots takes Draconium Dust with more cetane diesel, and it takes 6,800 degrees, which I think is higher than these coils go. Let's see. No, they don't. They go to 7,200. So then what do I need these for? Okay, that's cool then. Let's since we can cook these with Naquadah coils, let me go set up a assembly line or a production line for Draconium Dust, and we can immediately begin our Draconium production. I expected it to take a little bit longer than this, but hey, let's get right into it. So making Draconium Dust is pretty straightforward. Again, it's two chemical reactors. One makes Dragon's Breath out of blazing pyrotheum and cetane diesel. The other makes Draconium Dust out of Dragon's Breath and Manulin Dust. And then I'm just going to store them in drawers for now. Let's put some upgrades in these drawers. Let's just upgrade the Draconium one a few times. We'll leave the Dragon's Breath one alone. So now that we're making Draconium, we can go back to our blast furnaces and make sure one of them will cook it. So I set this one up here to make Draconium, and I want to set a slightly different termination condition for Draconium versus the other ones. The others I just stop once I have a certain amount of the thing it's making. Draconium, I just want to keep a little bit of dust on hand because there's a few recipes that require dust. But for everything else, I'd rather just automatically craft the dust into Draconium because we need way more Draconium than anything else. So let's configure our export buses. We need that and cetane diesel. Items go in here. Fluid goes in here. And this should start, For now, let me swap that just so we can run a cycle. And then once the first cycle's done, I'll show you we still have to do something with the hot ingot. So now we have a hot Draconium ingot. Unlike the other hot ingots, I don't think this one burns you. It's not actually like a hot ingot. It's a custom item, so we can hold it without it burning our hands, which is good. But hot Draconium, you can't just freeze it. You have to freeze it with jellied cryotheum. So I guess you have to super freeze it. So let's come over to our freezer and make sure we put jellied cryotheum into the input hatch. And we're already melting this stuff because we needed it for our reactor, so we get to reuse that infrastructure. And jellied cryotheum there. Send ingots here. And is it not freezing? What's the matter? Oh, I didn't plug it in. That would do it, huh? Let's try it after we plug it in. And it's freezing. And that should make our first Draconium ingot. Is that a quest? That should be a quest. That's a quest. Alright, unlocking Draconium ingots opens up a world of possibilities, but I think those are a world of possibilities for tomorrow. So, let's wrap this episode up here. I hope you enjoyed the episode, and I'll see you in the next one. Take care. Bye-bye.